in order to fit this alignment to this frame, here we have a scale of 1,334,230. When we minimize this scale to 1 million, we see that the objects are getting closer. It's getting near to fit to the frames. What if we change it to 750? It is near to fit the topographical frame, but it is not, it has not fit yet. And when we change it to 1:500,000, it fits, and some of its portion and some portion are zoomed beyond the extents. So we should try maybe a scale of maybe this much, 575,000. This can be termed as the best fit scale. Okay. Also, on the geological frame, we can also use the same value, 575,000. Since we have similar scales here, and we do not wish to adjust the scales, we can lock these frames. We can lock these frames so that the scales cannot be changed. So we right click on one of the frame, and we go to data frame, automatic, then we set to a fixed scale, which is 1:500,075, 575,000, 1:575,000. Then we click apply. So on this topographical frame, we cannot edit the scale here, and it is faint. And when we go to the geological frame, it is not yet faint because it is not fixed. We can also fix it here. Then we go to extents, fixed scale, and we select this scale, apply, and OK. So we have succeeded to fit these scales here. We cannot change the scales. By scrolling, you can scroll, but you cannot change the scales here. I'm trying so hard to scroll, but the scale cannot be changed. You can pan to move it up and down, but you cannot change the scale. So we go back to our data view. No, our layout view. So in our layout view, we can turn off some features on geological frames, such as polygons, and we should be left with these lines. On the topographical frame, we can customize the I do not know what happened. So we can change the polyline thickness to just by clicking it, and this dialog box opens, which is a simple selector. But we're not going to say yes.
Unaweza ukafanya tena ulichokuwa unakifanya?
Yes. We succeeded to plot the alignment in this in both frames, okay? Then after plotting this alignment on both frames, each came with category of data which is available in that KMZ file, which are categorized as points, polylines, and polygons. So we go direct to polyline after switching off the polygons, and we select the red line, which is the alignment of standard gauge railway. So we just click on it once, then we change the width of the line. After changing the width of line, when we click OK, we see that the alignment has been highlighted. And when we need to check the attributes of these polylines, we just right click on polylines and click Open Attributes table. So here we have the attribute table. How do we know that this is the alignment? When we select the first portion, section 1 and section 2 are selected, and when we select the second one, it selects section 3, and when we select the third one, it selects section 4. Section 1 and 2 were merged as one in this KMZ format. And when we need to unselect or clear selection, we just click on this symbol which is assigned clear selection. We can also calculate geometry of this, but this shape length here, which are available, are not the actual length of this, because we know the total length of this is 366 plus 0.73 meters. 366 kilometers plus 0.73 meters. So the shape length which are available here are not the actual length. But when we need to calculate the length of this, we should meet on the on next meeting, or when we have enough time in this. We're just left with 2 minutes, but I think we can add more minutes to ourselves. So we repeat the same procedure on geological frame. Click on the geological frame and click on the red line. Okay. Now, in order to distinguish these two, we should add data which is subjected to geological features, which is just geological context right in here. So go ahead to your folder connection and connect the folder where you saved maybe geological shapefiles. Right here, I have already connected some folders, which is Tanzania shapefiles. I can disconnect and connect again. I can disconnect this and connect again. So I'm going to connect for the beginners. you browse where you stored your shape files. So then you come and expand and search for those shape files. Maybe if we have questions, we can ask at the end of this at the end of this meeting. So right here we have managed to add the geological shapefiles. These geological shapefiles for the whole country of Tanzania. Maybe we should do one thing here. We can unlock this to extend to automatic, then we later on we are going to turn back to our fixed scale. So I think here we can see this is Tanzania, but it is rotated because we rotated our data frames to 270. So when we rotate it back to 0, it is where we can see the orientation of these values here. We can download these shapefiles, which from Geological Survey of Tanzania, from the website, which is you just write Geological Survey of Tanzania, then it will direct you where these shapefiles are located. You just need to scan a little bit, and you will be able to see them. So here we're just going to deal with symbology of this so that we can see our alignment. We can remove the fill color by going ahead to geology here and remove fill. We just click on no color, then okay. After okay, you're going to be able to see what the different geology of this Tanzania and the alignment from start to the end. So from start to end, we're going to be able to see that the railway alignment crosses different geology. Is that okay? I think it is okay. But in order to be clear with this geology, we need to label them. We can label them and put different color codes so that we can be able to distinguish one feature to another. So right on geology, we are going to go to properties and symbology. We are going to assign colors to different parts so that we can be able to know where is granitoids, where are mafic rocks, and where are metasediment complex. We're just going to be to see them here. So right on symbology, then categories. we're going to choose lithology, and color ramp can be selected to according to what you desire to see, or what you desire this presentation could look like. Presentation of these colors, presentation of this of lithology, you can assign various colors here. So just select the one which you desire and check all other values, then add values. The one which is not having any heading or lithology, this is going to be water bodies. And it is better to assign blue color to this. Maybe we assign it to lake. And when we apply this, we are going to see that we have assigned different colors to these attributes which are lithology. A deep understanding of these things, these shapes, you just go to the Geological Survey of Tanzania and read it one by one slowly. You'll be able to understand it. But here we have just one problem. We do not see our railway alignment here. So I think we should just drag this down so that the display order can cause this to go up. But it seems to be difficult a bit to drag this. So here we're going to zoom to we're going to rotate it back to 270 degrees. To this scale again. So when we turn off the geology, we will not be able to see what the geology shapefiles. But when we turn on this, we're going to be able to see it. So maybe we should come with one solution here. Display. Maybe we should set this the transparency maybe to 60%. When we set the transparency to 60%, we're going to see it. We're going to see the alignment, right? We see the alignment very clearly. I think this is satisfactory. On the topographical frame, I think it is in order to know where we have different conflict points, like existence of road underpass, railway bridges, drainage culverts, pedestrian crossings, livestock crossing. We need to have some desktop data which we just reviewed either from the internet or by reconnaissance survey and locate those conflict points. So here we have just few desktop data. We can import Tanzania waterways here. So where we have seen that these features cross the alignment is where we can locate the structure so that the standard gauge railway can pass over this or across it. And we also have road shape files. We can also import them in here. So we have different interactions here. We also have MGR, meter gauge railway. So this meter gauge railway, we are going to customize it a little bit and assign rail symbols. Maybe you're going to use black color of width of 3. So whatever we added in topographical frame did not add into geological frame here. Also, we have we can also add the elevation data. Elevation data can be obtained from different sources, including Global Mapper, including United States Geological Survey. But in my case, I downloaded the terrain data from United States Geological Survey. I obtained it as tiles, which a certain area zoomed beyond the extent of this alignment lot 5 crossed those tiles. I think maybe on the next meeting we can discuss that. So I think it is right here. We're going to connect this folder and browse where I located the digital elevation model. Here are the tiles S03, 32, 33, 32. They were just 6 tiles, but I combined them to a single merged file, TIFF format, which is I labeled it as CCDEM. CC to my side just stands for Central Corridor, but it is not necessary to call it Central Corridor. I called it Central Corridor because when we examine the position of this alignment is at the center of a country, so we can call it Central Corridor Railway. But from Dar es Salaam to Morogoro, maybe we can call it Eastern Corridor, coming to Central. So you can just drag it on the topographical frame, and there it is. Then we can go ahead to change the, we can change the properties of this. Instead of having this key from faint gray to dark gray, elevation are decreasing. So we can just customize it to different color ramp. You can use a stretched or you can use classified format. And in both cases, we also have a hillshade effect. Hillshade effect is going to enable you to see the appreciable terrain model, where there are depressions and where there are hills. So when you check on hillshade effect, you're going to see that effect. I think we can all appreciate the terrain model, where there are hills and where there are depressions. Or you can change the color. You just select any color ramp which you wish to use and apply. This color cannot present the railway alignment. Maybe let's try another color. This can present the railway alignment, but maybe let's try different colors. This can present the railway alignment, but whatever color you think you can use and present the alignment clearly and other features clearly, you are allowed to use them. It is going to be your choice. If you don't wish to use this, you can invert. Maybe that is enough. You can go back to data view. So before ending this, we can also add grids. Go ahead to properties, then coordinate system. We can use, to our case, the projection is universal transverse Mercator. Then we go to Africa. Then we choose ARC 1960. Then apply. Yes. Then okay. Okay. We have succeeded to set the coordinate system. Then it is time to add grids. Go to grids, go to new grid, go to measured grid, then next. Instead of using lines, we can use ticks as shown here. Maybe we can use same interval, 10,000 meters. 10,000 meters means 10 kilometers. Next, finish, then apply. Then yes. I think we can see the plus signs. If the plus signs are very close, you can just change the interval. Let's say to 5,000 at the interval of 3,000. intervals. On intervals, maybe you can set 50,000. Apply, okay, apply again. Now from here we do not have very dense grids. Maybe we can just reduce it a little bit to half of the interval. Then these grids are not clearly seen. Maybe we should also customize the size, the font of these grids. I prefer to use Times New Roman font of size 12, bolded, and we're just going to assign it to top and left, top and left, top and left, right and bottom. We're going to leave that space for latitude and longitudes. So on labels, we can just change it to Times New Roman, and size can be 12. It is bolded. Then we just uncheck bottom and right. Okay, okay, apply, okay. So we succeeded to remove on right and bottom. We can also add new grids, which are graticules. Graticules are those meridians and parallels, which are latitude and longitude. We can also use plus sign, or we can use maybe different format. Maybe we can use a cross here. We can change the color to red and click OK. In the interval, maybe let's try with maybe 1 degree. 1 degree is too 1 degree. The preview shows the actual appearance of these grids on our topographical frame. So when we increase this, it is how it is going to appear on our frame. I decided to put an interval of 10 degrees. But 10 degrees, we cannot see anything here. So let's try to reduce. Instead of 10, let's try to put 15 minutes and see the effect of this. At least 15 minutes makes sense. And go ahead to labels. On labels, we can also omit left and top, so that the labels do not interact. We uncheck top and left. We also change it to Times New Roman, and we use font of 12. We bold this. Then vertical labels should be right. I think we have set very clearly grids on the topographical frame. Now let's move to geological frame. On geological frame, I need to add labels. I need to add labels on this